Hello everyone, hope you are doing well. Welcome to Excel for Data Analytics 10 days challenge, and this is day number 8 where we are going to see Excel statistical functions. We are going to see statistical functions that you can use in Excel. This is most advanced and important lecture for you guys. This is not covered on YouTube. You will find this only in paid courses, so stay tuned for this lecture. You'll be able to learn each and every statistical function used in Excel sheets. Okay, all the resources which are available and used in this lecture are available in the description. You can go there and download. Okay, so let's get started. In this lecture we are going to see Excel statistical functions like median, mode, variance, standard deviation, quartile and percentile. So I hope you will understand each and everything, because these are basics maths or statistics we have learned in our 10th and 12th standard. So you will get to know each and everything, and obviously we are going to see only concepts and we'll use them as a formula. Okay, so I hope you'll learn each and everything about the statistics in this lecture. Also, whatever I am teaching in this lecture or whatever I am sharing with you guys, all the PPTs and the Excel sheets are given into the description, so you can go there, download and practice it. So now in this lecture we are going to see Excel statistical functions, and this is most important topic. Mostly the people who are becoming data analyst as well as they are looking to become a data scientist. Okay, and here we have 6 functions including median, mode, standard deviation, variance, percentile and quartile. So these are 6 functions that we are going to see in this lecture, including all the important variation of these formulas. In these formulas there are multiple variations, plus I will cover each and every point regarding that functions. I'll explain you the statistics behind that function and then we'll solve some problems. Okay, and whatever I am explaining to you guys, all this PPT and the examples which I am going to take in this lecture will be there in the description. You can just go to the link and download and you can practice it. Okay, also please let me know how these lectures are going. If you are liking it, please press the like. If you have any feedback, like in last lecture somebody commented, please zoom in the screen, because we are not able to see the lectures on mobile phone because their Excel sheets are involved. So I'm trying to make it more zoomable and will provide that lecture so that you will be able to see it properly. Okay, so please like the video and subscribe to the channel. Okay, so let's get started. This is our first point, which is median, and in this we are going to see what is the difference between median and the average. See, average is different concept and median is different concept. Median is middle value, average is average per value. Okay, now how let me explain it. So first of all, let's consider we have 10, 20, 10, 20. Okay, so average will be around 15, right? But if I am writing one more like 1000, okay, the average will go up and it will be around more than 100, right? 100 plus. Okay, but average will not give you idea that 4 values are there which are below than 20. Okay, 20 less than equal to 20. Okay, this you will not be able to understand by using average. But whenever you are taking median will help you to understand what is the range. So here for the example, these are the values 10, 20, 30 and 1000. Now if you are taking the average, then it will be almost more than 1000, more than 100. But if you are taking median, then the answer will be 25. So you'll get to know that there are lots of values which are around 25. Okay, this is median. Now much better than average when data has outliers. So this lecture mostly will be around outliers only. Now what is outliers? Let me explain you. So this is your line. Okay, this is your average line. Okay, now this is Jan, Feb, March, April, May, June, and this is your line. Okay, now in Jan you have profit of 10%. In Feb it was 5%. In March it was 100%. In April it is lesser again. In April, in May it was negative. In June it was positive. So this graph, okay, this graph is having outliers. Okay, this is your outlier number 1. Okay, this is your outlier number 2. So to determine this, okay, because this will be always a part of a data analyst job where you are going to see whether the data is stable or not. Means on this data you'll be predicting your performance for July, August and September, upcoming 3 months. But because of these outliers you need to assume multiple things, because this is 100, this is in minus. Okay, so to consider that projection you need to consider few deviation and the outliers. For that we'll use multiple things, but right now we are learning only this median. In median you need to just select the median value. Okay, and this is your median value. Now let's solve some problems, because the formula for this is very easy, like sum. For sum we'll write sum and we'll select the range. Okay, right? So same here for median also, we'll write median and we'll select the range. Okay, now this is the problem, very easy. We need to find the median for this sales. So I'm writing here formula. Okay, median, and I'm selecting it. Okay, so this is your answer, 50,250. Similarly I'm writing formula for this also. Okay, this is 55,000 and this is 50,000. Okay, let's find average for these things also. Okay, so average will give you some idea how different it is from the average. For this average will be almost similar. Let's see average for this value. Yeah, average is almost same. Okay, now if I'm trying to change this value to, let's say 150, 1 2 3. Okay, see, this average has changed, but your median is as it is. Now I'm trying to make it 1,85,000. Let's see how much difference it will be there between median and, see, median has changed, but your, see, average has changed, but your median is as it is. So from this you can say that outliers will be neglected because of the median value. Okay, average will consider outliers also. Okay, so if I ask you as a manager or as your senior person, ki what is the sales trend, you will say, see, Jan, Feb, March, April, May, the sell trend is almost flat, but in June we have found some spike. But it is not sure that in July also you will get same profit. Your profit margin will be around this only, 50 to 50,000. Okay, 50, near about 50,000. You cannot say it will be around 1 lakh. Okay, so that's the difference between median and the average. Okay, so median you will consider whenever it will be projection. Average mostly you will not consider because outliers will be there. Okay, so I hope you understood this thing also. Now next thing is mode. Now what is mode? Mode is the return most repetitive value in your array. Now what is most repetitive array? So simple, the example is here. For example, we have these values here, 4, 5, 5, 3, 5, 4. Okay, 4, 5, 5, 3, 5, 4. Now you can see 5 is repeated thrice. Okay, 4 is repeated twice and 3 is repeated once only. Okay, and here it is repeated. Okay, when you have multiple values like 1000 values and you want to know which is its most repeated value, then you will use the mode formula. Now in mode formula there are multiple variations. So here, for example, if you have these values and you are using mode, then you will get output as a 5, only one value which is most repetitive. Okay, now this is most commonly used in order quantity. For example, you have a commercial store where you are selling your orders and you want to see how many orders you are getting frequently. For example, you are selling tennis balls. Okay, now in tennis ball most of the people are ordering 2 balls at a time. So you will give this insight to your manufacturing team or a planning team ki most of the people are buying these balls twice. Okay, they are ordering 2 balls at a time. So the team can decide whether how many balls they should pack. So from next time they will introduce one more pack where you can get 2 tennis balls in one package. Okay, so your packaging material will be saved, and plus you are it is easy to buy for the audience. Okay, for the customer, they can buy it. You can send more offers, or you can increase the price, you can decrease the price, whatever it is there. But yeah, this will be helping you. Okay, then most frequent rating. So this is customer rating. We saw like what customer rating: 3 star, 5 star, 4 star, and a popular product size. Okay, similar usage are there, so you can use this. Now there are 2-3 things. Okay, let's go to our Excel sheet and let's see what we can do with MODE. Okay, so these are customer ratings we are having, and we are solving this with using MODE. So normally there are 3 function in MODE. So you can see here. Okay, there are 3 function: MODE, then MODE.MULT and MODE.SNGL. So right now I am using MODE. Okay, and I am selecting the range. Okay, this is the same as a sum formula. You need to write and you need to select, and it is giving you 4. So if you can see here, 1, 2, 3. So 4 is repeated thrice. Okay, the 5 is repeated thrice. Let me change the color. And 3 is repeated once only. So 4 is repeated thrice, 5 is repeated thrice, and 3 is repeated once. Okay, now let's understand while using PPT. So there are 3 functions right now. Is MODE first one, second MODE.SNGL, and third is MODE.MULT. Okay, now here legacy function means when they created a Excel by Microsoft, when they created that, they introduced this function. This is right now outdated because this returns the single most frequent value, but it is having flaws. Okay, second is Microsoft itself suggesting using MODE.SNGL instead of MODE only. Okay, so we'll use MODE.SNGL. This is the option. Okay, here only you will get output 4, here also you will get output 4, but here returns one most frequent value. Okay, same thing, most frequent value, here it also you will get, but the difference is here you will get any random value. Sometimes you will get 4, sometimes you will get 5, and this thing. Here what will happen, let's write this. Okay, let's write this function. Here we are using MODE.SNGL and I'm selecting this. Here it has written 4 only, here also, here also. But here the logic is returns the smallest number value when there is a tie. Means 4 1, 4 twice, 4 thrice. Here 5 once, 5 2, 5 thrice. Okay, but it is giving you output 4 because it will consider always the smallest value. So 5 is greater than 4, 4 is smaller than 5, that's why it is considering 4 as a value. That's why your output is 4. But now you'll ask me, but what we want both the values, because 4 is there 3 times and 5 is there 3 times. Then we'll use MODE.MULT option. So this is returns all the values that occur most frequently. So here you will get output 4 4 4 3 times, 5 5 5 3 times. So you will get this answer. So if I solve this here, MODE.MULT, if I use same formula MODE, and if I am selecting the range, so you will get 2 values, 4 and 5. Okay, 4 and 5. So you will get 2 values over here. Okay, so in this way MODE will work. It's easy formulas, just need to learn the concept, just need to remember the concepts. Formulas are very easy because in Excel whatever you will click on is equal to, and if you write first or second letter you will get the formula as it is. It will show you hints also. So it is very easy to use Excel. It's not complicated thing, but you should know the concept behind the formulas. Okay, now let's go to next thing, which is again MODE. We'll see the comparison. See Excel version. Okay, for MODE old version. Okay, old. This both MODE.SNGL and MODE.MULT both will be having for modern. Okay, returns one mode. Here also one mode because this is single, this is multi, is that's why it will repeat values. It can show you 2 3 4 and numbers of values if those are frequently written. Okay, then multiple modes. Okay, this return one, return first smallest, and this is written all. Okay, all it will not compare, this will compare. Okay, this is the multiple modes logic behind it. Okay, recommended to use, this is not recommended, this is recommended, and this is recommended. Output type single value array. Okay, it can show you multiple things also. Also remember one thing, if for example I am removing this formula, okay, and if you have some value over here and if you are writing that formula here, so it will return spill. spill is a error that will return, because if you click on here, spill range isn't a blank, means the value you should get out of this formula, it's not able to reflect because there is a already text here. So if I remove the text, then the formula will work. Okay, so this you need to take care of. Okay, now let's go to next function, which is standard deviation. Standard deviation, you have heard about this in 12th standard most probably. So we'll learn this very easily. Okay, we'll not go into too much depth, but you will get overwhelmed because seeing these formulas. These are very simple formulas. I will explain to you. Now standard deviation will use to consider outliers, how far these outliers are. So I have explained you this, right? There was one graph I was saying ki if for example this is your line, okay, this is Jan, Feb, March, April, May or June, okay, and you have this value like this. If your values are like this, so what you will do? Okay, so because these outliers are very big, so to calculate these outliers, how many outliers are there, means whether these outliers are making any difference to your calculation or not, to calculate that we'll use standard deviation. Okay, so I have something here. See this graph is very stable. Okay, this is very stable, it's not going up and down. This is not like zigzag, which is here. Okay, it's very zigzag, right? This one is very zigzag. This is very flat, right? So this is the use of standard deviation whenever we want to see whether these values are unstable, volatile, or a consistent performance. According to the standard deviation will decide what is it, whether it's a low standard deviation or high standard deviation. So this is the graph of high standard deviation, because the deviation is very high. Here it's not that high variation. Okay, so to calculate this thing we'll use this. Now the question is, we have multiple formulas here, what's the use of it? Okay, now let me explain you. We have a third sheet over here. Now, so standard deviation will have two formulas. One is sample data and second is population data. If you go to back sheet also, sample data, population data. Okay, this I have written in that sheet also. To explain what is this sample data and population data. So sample data's formula is this and the population data formula is this. Okay, so you consider this n as a capital N, this n and this n is same. Okay, now what is sample data and what is population data? Now let's consider you have some sample data of some virus. Okay, now let's consider you have something, for example you have one pill, okay, and you have given that to 10 people who are trying to lose their fat. Okay, you have given that pill to 10 and this is the number that you are getting. Some person has lost 10 kilo of weight, some 9, 10, 10, 10 like that, and like that you have sample of 9 people, but you are not confirm about 10, 11 and other, you have 1000 more people. Okay, because you have sample of only 9 people. So because you have people of only 9, you have sample of only 9 people, you will assume remaining values. Okay, so this sample data will have some assumption. Okay, this sample data will have some assumption. That's why for the sample data we'll use this formula. Okay, standard deviation, yes, which is sample data, and the formula for this will be this. Okay, but whenever you will have population data is the term for it. Okay, it's not actual data, but when you have, you have tested that pill on 11 people. Okay, and you have exact data of those 11 people, so you can do remaining calculations on the basis of that 11 people, and that's why you will use this formula. But on the population data, you have implemented that 10, 11 whatever pills are there on 11 people, and you have exact values for all 11 people. Because you have all the 11 values properly, you are not assuming any data. So for that you will use this population data. For that the formula is this. Now what is the difference between this formula? Here it's n minus 1 and here it is only n. Okay, here only n and here n minus 1. Okay, that is the only difference. But the good thing is you don't need to write this formula in Excel sheet. You can simply use these things. Okay, so this is about the standard deviation. Let me repeat you. So basically standard deviation we will use to just confirm about our data, whether it's consistent or it's unstable or it's a volatile data. Okay, for that we'll consider few points. Okay, we cannot draw the graph for it because it will be in thousands and millions, so that's why we will use this formula. Okay, and the formula for it is very easy. First is you need to just write equal to, then you need to select standard S, standard deviation S or standard deviation P. Okay, and the range. That is the only formula, same formula. Okay, so we have questions to solve. So this is the standard deviation formula for us. Okay, now we'll write the formula over here. Okay, is equals to standard deviation. So his standard deviation is there. We are using this one because this standard deviation only formula, it's outdated by Microsoft. So we'll use standard deviation. This is our sample or popular. So we'll calculate both. Here we are selecting standard deviation yes, okay, which is sample one, and I am selecting these values because start is 0. I just put that number to just show this graph. Okay, so I am not considering that. So this is your number. Okay, let me format this number with the normal number. Okay, and here also I'll format this. Then I will again calculate standard deviation singular for this also. Okay, and it will give us some value. So the here is standard deviation dot s, which is sample, and this is standard deviation dot s sample again. This is, then I am writing here dot s, and we'll do same for the population also. We'll write population formula over here. So I am writing here standard deviation again, this population. I am selecting this data here. Okay, here also just remember this data variation will not be there too much, like S and P, that difference will not be there too much because it's only n minus 1. Okay, and you have 10 more values or 11 values. Okay, that's why it will not make that much difference. Okay, so this is the thing. Now how you'll consider whether your data is volatile or not, whether the data is having very high volatility or not, how we'll decide? For that we have simple formula. Whatever we are having here, you can see here. Okay, so this is our standard variation. You can consider any. I am just removing this. We are not considering this. Okay, we don't need this. You can calculate according to your choice. You can use standard deviation sample or population. So we have standard deviation here and we have standard deviation. Now I am asking you, from graph it's very easy, right? It's, you can say easily ki this first data, which is this data, is not that volatile, so because it's very stable. Second one is totally volatile because it's going up and down, up and down. But you don't have graph, for example. What you will do, how you will calculate? For that, simple trick is there. So how you will calculate now, because you have these things. So for that I have one more slide, which is this one, standard deviation, low versus high standard deviation. How we will calculate? So whatever standard deviation we got, so we got standard deviation for this is 566 and for this is 33,166. Okay, so we will divide this standard deviation by average or a mean. Mean means average only. Okay, we'll divide that by average. So average I already have here. So what I'll do, I will write formula is equals to, this is standard deviation divided by average, and I will get some answer. Okay, here also I am doing it, standard deviation divided by average. Okay, and I am converting this into percentages. Okay, so I am selecting this, converting into percentage. Okay, so this is coming around 1% and this is coming around 60%. Now this is the chart. You not need to like remember this chart. You can easily go search on Google and you can get this. So variation is always judged on the context, where if your value is less than 10%, then it's very stable. If it is between 10 to 20, it's acceptable. If it is between 20 to 30, it's high variation. And if it is greater than 30%, then it is very volatile or risky. You cannot do prediction or projection on the basis of more than 30% of standard deviation. So your coefficient of variation, which is CV, it's lesser than 10%. That means it's very stable. Okay, so I'm writing here it's very stable, and second value is greater than your 30%. That is, it's volatile and risky. So on this basis you can calculate these things. This is advanced Excel. Welcome to advanced Excel, and I hope you will understand each and everything when you will practice it. Let me revise it. First of all, we have two things. First is, let me go to the slides. Okay, so we have standard deviation. Standard deviation will help you so that you will consider, or you will get to know how far your values are there from the average. Okay, and these are the two formulas. One is sample data and one is population data. Sample data will be there because whenever you don't have complete data, you will assume something, then you will use sample data. But when you have complete data, you will use population data formula. Okay, and this is the difference that you can see on the graph. This is your low standard deviation, this is very high standard deviation. But whenever you want to see how your deviation is very high, then you need to take a standard deviation divided by average of values, and if it is lesser than 10, it is very stable. It is between 10 and 20, then it's acceptable. If it is between 20 and 30, then it's high variation, and if it is greater than 30, then it's volatile and risky. Okay, so on the basis of this table, you can see this. We have calculated multiple things. First is we have taken average. Second, we have taken standard deviation, and this is a sample data standard deviation. Okay, and we have divided our standard deviation by average. We got 1%, and according to this table, it's very stable. We can calculate other things on the basis of the data. But the second sheet or second table we are having, which is having very high volatility, we have seen that on the graph also. But we calculated the average, then we calculated the standard deviation, and on the basis of the standard deviation we have calculated CV, which is coefficient of variance, and it is giving us volatility, and it's very risky to calculate anything on this data. So I hope you understood about standard deviation, and it's very important topic that you should know about data analytics. Now we'll go to next formula, which is variance. Now variance and the standard deviation, it's same. Okay, how I'll tell you. So see, you can see here, so standard deviation is equal to square root of variance. Okay, so if I'll say variance is equals to standard deviation. Okay, so standard deviation, whatever, let's say if you are getting 10 as a standard variation, your value, but if you want to calculate variance, then just square it, which is 100. So 100 is your variance. Okay, usually we'll not use variance because same as standard deviation but square and less intuitive. Okay, mostly using statistics and analytics, not day-to-day reporting, because it's squaring the things. Okay, both variance and standard deviation measure how spread out data is from the mean. Same thing. Okay, same. For example, you have this line and it is calculating how far your outliers are there from the average. Okay, you can see same but different. You can see here standard deviation. Okay, standard deviation is having values in singular format, while same value it is there is squared because it is variance, so it will square your value. And if you see rupees cannot be square. Have you seen rupees square? Okay, that's why it's less intuitive and will not use this value. But obviously because we are considering each and everything, so we'll solve some problems. So I am writing here whatever standard deviation we have calculated. So standard deviation for this is 566, standard deviation for this is 33,100. Okay, so this is standard deviation we have calculated, and let's say this is INR, or let's say it's very easy, it's dollars. Okay, it is in dollars. Now we'll calculate variance. Okay, and variance also have two things, popular and sample. So as we have used sample for the first formula, we'll use sample over here also. Okay, clicking on enter, see the value variance. Similar, we'll use variance here also. Variance single, we'll select here. Okay, see your value are going out of the roof. Now if I take a square root of this, okay, so I am writing square root of this value. Okay, 566, almost 566. if I reduce the decimals, here also I am taking a square root of this value. See, this value and this value is same. That means your variance is nothing but a squared of your standard deviation, and that's why you'll use always standard deviation. Okay, I hope you understood variance also, and it's very easy. So if you learn about standard deviation, then it's very easy to learn about variance. Okay, now let's formalize percentile. It is again easy thing. So in percentile, wherever you want your value in percentiles, you will use this formula. For that we have formula this one, percentile. Okay, and this is range, and we'll use E and C including. Okay, it will not use EXC. Okay, we'll use including. This is the range. For example, we have some values over here, so we'll select that range and we'll here write K. K is what? K is our percentile, and you will write between 0 to 1. Okay, I will explain this with the formula in our sheet. This will be using your salary benchmarking, top 10 performers you need to select, or exam cutoffs. This will be very useful. And for example, we need to find 19th percentile value. Then for example, we are right here percentile include here the range A1 to A100, and here as we need 90th percentile, so we'll use 0.9 over here, and it will give you value of 19th percentile. Okay, so we'll solve this problem on our Excel sheet. Here it is asking, so we have students, almost 50 students we are having, and their scores. So it is asking what is the 50th percentile score. Okay, so it's very simple. It is asking us if I want to shortlist a person of, or I want to know what is the score for a person who got a 50 percentile. So how I'll get? So for that I'll write formula here. I will write percentile. Okay, percentile. Now there are again three functions, you can use any. I am using for percentile inclusion. Inclusion means whenever you have the array, whatever you are selecting, it will include those values. I will not click on exclude. Include is a very accurate function for this. Okay, so I'm clicking on this and selecting all the students. So we have selected all the students, comma. Now I know I want 50th percentile, so I write 0.50. Okay, and I will close the bracket. Okay, so this is giving me a value where 50th percentile student will be there. Now it is asking what score represent 25th percentile. What score represent 25th percentile? So it's very easy. Same formula. We'll write percentile over here, inclusion, and we'll select the array. Okay, and comma. We need 25, 0.25. Okay, bracket complete, enter. This is your value. Okay, according to that you can solve these problems also. It's very easy to solve these problems. Okay, so these are your values that you are getting. Okay, according to this you can solve percentile also. Now let's go to next function, which is quartile. It's again simple. Okay, it is not having anything into it. It's only having a simple thing, which is it will convert your values into multiple values. So like that, here you have things, right? Here you can put 90, here you can put 0.753, you can put 0.45, like this 45 percentile, 40.30 percentile, like this you can select here. But here there are no option. There are simple option. 0 will be there. Okay, 1 will be there, 2 will be there, 3 will be there, 4 will be there. Only these formulas you can use for this function. Okay, so you have divided data into 4 equal groups. These 4 equal groups are there. If you want any data in these 4 groups, you can use this function. Okay, for that we'll use quartile.inc, range and quart. Quart is this, we'll use this quart, 1 2 3 4, whatever it is there, whatever we need. So if you want bottom 25, okay, you will use 1. If you want midden, you will use 2. If you want top 25, you will use 3. And if you want max value, then you will use 4. So what is the meaning of that? So this is the, let's say 100% thing we are having it here. Okay, now I want to calculate the person who is bottom 25. Okay, if there is one threshold where I want to know the number of here, the student who is having 25 percentile score. So we'll use quartile includes range 1, because if you see this if you want bottom 25, then you will use this. So you will get this value, which is 25. If you have 100 values, then you will get 25th value. Okay, if you want median, simple, we have middle value. For median, we have our formula, which is median, which we have seen in first function only. You can use this formula also, quartile.inc range comma 2, and you will get middle score. If you want 75th one, then you can use quartile top 25 student scores, mean whatever value. For example, here we are getting 340 value, then you will say above 340 marks, every student is in top 25. Okay, and the highest score is nothing but maximum score. Whatever score you are getting, you write quartile.inc range will be 4. Okay, or you can use our function, which is max directly, and the range. Okay, this is the use of our quartile function here we are going to see in this sheet. Okay, so it is asking highest score. So for example, you want to highest score, then we'll write quartile inclusion. Okay, we'll select the range over here. Okay, and we want max, so we'll select here. See, it is written here whatever you want. So minimum value is 0, maximum value is 4. So I'm selecting here, and this is your maximum value. So 495 will be your maximum value. You want top 25 students, simple, you write formula here, quartile inclusion, you select the array here. Okay, and you give the comma, and you select the 25th percentile. Okay, so it will give 25th percentile. Similarly, you can select for the median student also. Similarly, you can write the quartile inclusion form, and then you can select this comma, and you can select the median value, which is your 25th. So your 50th student. Okay, so according to this, you will get the quartile formulas. Okay, these two problems you can solve by yourself, and this will be your quartile function. Okay, so this is all about your statistics function, where we have learned about median. In median, you will get middle value, and this is your formula. So if you observe first 4 formulas, median, mode, standard deviation, and the variance, is having only a range formula. So it is nothing to remember about it. Just need to remember if it is median, which is middle value. If you want to find most common value, then use mode. If you want to find what is the data consistency, whether it's volatile or consistent, then use standard deviation. This is variance. You should know the concept only, no need to remember it, but yeah, you can remember it. It's just remember the variance is nothing but square of standard deviation. Okay, percentile, rank based cutoff, it's a very easy concept. Okay, and data distribution, if you want to divide into 4 parts, you can use quartile. Okay, percentile, so you already know, because everywhere it's percentile nowadays. Okay, so yeah, I hope you understood each and everything about this, and now we have only 2 lectures left. First will be your charts, I guess, and then data cleaning. So guys, I hope you understood each and everything about statistics in Excel. You can use all these functions, practice it by going into description, download the Excel sheet, and by practicing it. Okay, so next lecture we are going to see how can you clean the data in Excel sheet, because you have learned about all the formulas and the functions. Now we are going to focus on data cleaning. Okay, this will be last second lecture, because that will be day 9. So see you in the next lecture.